Welcome to Study Loop.
So at an archaeological site, we find 500 grams of timber, and the carbon within that decays at a rate of 2690 decays per minute. We're asked to calculate the age of the sample from this. So, as you might have guessed, we're going to use the exponential decay formula. So we know that the number of decays per minute at some time is equal to some initial value of decays per minute times e to the minus lambda t, where lambda is our decay constant. We can calculate lambda, as usual, from taking the natural log of 2 over the half-life, and this just comes from the definition of what the half-life is. And if we calculate this by plugging in numbers, we find a value of 1.21 times 10 to the minus 4 years, using the half-life of carbon. Now the next thing we want to calculate is the activity in becquerels per kilogram for this particular sample. So because we have 500 grams of carbon and we're decaying at 2690 decays per minute, we know that the activity is equal to the number of decays per minute over the masses of our sample, which again is 0.5 kilograms or 500 grams. And this works out to be 89.7 becquerels per kilogram. Now the last thing that we have to know is that for atmospheric carbon, the rate of decay is given by 255 becquerels per kilogram, as pointed out in the chapter. So the last thing we have to do is solve this equation for t and plug in the values we have to find out the total age of our sample. So solving for t by taking the natural log of both sides after dividing by a naught, we find that t is equal to ln a over a naught times 1 over lambda. And plugging in numbers for all these known quantities, we find a value of 86, 40 years, age of our sample.